Welcome back to Mr. Vaughn's classroom. Before we get started, I'd like to remind you to please click the subscribe button so that you get notified anytime I release one of these videos, as well as give this video a thumbs up to help out the channel. Today we are on Unit 4, Functions, Lesson 6, Features of Graphs. Our learning goal is to use graphs of functions to learn about situations. We have two learning targets today, and these are the two things you need to keep in the front of your mind as we're working through these practice problems. Make sure you understand these two learning targets, and if by the end of the lesson you're not quite clear on either one of them, please ask questions so that I can get you the help that you need. Learning target number 1, I can identify important features of graphs of functions and explain what they mean in the situation represented. We're going to talk about things like intercepts, maximums, minimums. You want to be able to look at a graph, pick those points out, and explain what they mean in the context of the specific situation that they are representing. Learning target number 2, I understand and can use the terms horizontal intercept, vertical intercept, maximum, and minimum when talking about functions and their graphs. Now, the intercepts, you've probably heard us reference them before, but you've probably heard the term horizontal intercept referred to as the x-intercept. Okay, so the horizontal intercept is where it's crossing the x-axis, the axis that goes horizontally. The vertical intercept is your y-intercept. It's where it crosses the axis going vertically up and down. Maximum is going to be the highest point. Either you're going to have the overall maximum at the highest point on the graph, or you might talk about a local maximum within a certain area of the graph. And finally, minimum. We might also talk about the minimum as the lowest point on the entire graph, or we might talk about it as a local minimum where we're only looking at a portion of the graph, and that is the lowest point in that portion. As far as glossary terms go, we have a decreasing function. A function is decreasing if its outputs get smaller as the inputs get larger, resulting in a downward sloping graph as you move from left to right. A function can also be decreasing just for a restricted range of inputs. For example, the function f given by f of x equals 3 minus x squared, whose graph is shown, is decreasing for x is greater than or equal to 0 because the graph slopes downward to the right of the vertical axis. If you notice, they've made that right side of the parabola bolded to make it stand out and show you that everything from x equals 0 to the right results in a decreasing y value. Next, we have increasing function. This is going to be the exact opposite of a decreasing function. A function is increasing if its output gets larger as the input gets larger, resulting in an upward sloping graph as you move from left to right. A function can also be increasing just for a restricted range of inputs. For example, the function f given by f of x equals 3 minus x squared, whose graph is shown, is increasing for x is less than or equal to 0 because the graph slopes upward to the left of the vertical axis. Again, if you look at this graph on the bottom, the parabola on the left side now is bolded because you can see that as we are moving from left to right and those x values are getting bigger, the y value is also increasing and going up for every value of x that is either equal to 0, which is at the top of the parabola, or when x is less than 0, which is everything on the left side of the parabola. Maximum. A maximum of a function is a value of the function that is greater than or equal to all the other values. The maximum of the graph of the function is the corresponding highest point on the graph. So just to make it very clear, when we are talking about a maximum, we are talking about the maximum y value, or the maximum vertical value. Okay? So we're only looking at outputs when we're talking about the maximum. Minimum. This is going to be the exact opposite of our previous term, maximum. The minimum of a function is a value of the function that is less than or equal to all the other values. The minimum of the graph of the function is the corresponding lowest point on the graph. So again, we're talking about the lowest y value. We're talking about the lowest output. So on the graph, the point that is furthest down when we're comparing it to any other points on the graph. Next, we have vertical intercept. The vertical intercept of a graph is the point where the graph crosses the vertical axis. If the axis is labeled with the variable y, the vertical intercept is also called the y-intercept. Also, the term is sometimes used to mean just the y-coordinate of the point where the graph crosses the vertical axis. The vertical intercept of the graph y equals 3x minus 5 is the point pair 0, negative 5. Or sometimes you can just refer to it as negative 5. Now we can begin the practice problems for lesson 6. This graph represents Andre's distance from his bicycle as he walks in a park. Notice we're going to have time in seconds as the x-axis, and we're going to have distance in feet as the y-axis. So as you see the line increase to the right, you are increasing the seconds since Andre began walking in the park. As we are increasing the y, we are increasing the distance from the bike. As we begin to lower the value of y, Andre begins walking towards his bicycle. Now, decide whether the following statements are true or false. Number 1, the graph has multiple horizontal intercepts. Remember, left to right is horizontal. So they're saying this graph touches the horizontal axis more than once. And we see that happen right here. And we see that happen right here. So there are, in fact, 2 horizontal intercepts. Therefore, statement 1 is true. Number 2. A horizontal intercept of the graph represents the time when Andre was with his bike. So when I am on this horizontal axis, the distance from the bicycle is 0. So anytime we touch this, our distance is 0. That means we are with the bike. So again, this one is true. Number 3. A minimum of the graph is 17.1. That means we would be at 17 seconds, and then we would be at 1 foot from the bike. But we already said we have x-intercepts at the beginning and end of the graph, and those horizontal intercepts are going to be even lower than this point at 17.1. So this would be a false statement. The minimums are going to be at the horizontal intercepts. Number 4. The graph has 2 maximums. So we need to look. We're looking for the largest y value or the highest point vertically. And we see that point right here. Now, if you look very closely, they're trying to get you to believe that this point over here at 9.8 is the same as this point over here at 21. But you can see just a little bit of white space under this point. That means the point at 21 is about 8.25, and the point at 9 is 9.8. So there's only one maximum. So this would be a false statement. And number 5, about 21 seconds after he left his bike, so we need to go over to 21, he was the farthest away from it at about 8.3 feet. And that is the point we just identified in number 4. Because this is at 8.3, that is farther away than when he was 8 feet away after 9 seconds. So this is true. The maximum is 8.3 feet at a time of about 21 seconds. If you have any questions about how to interpret a graph in order to answer questions about the situation the graph represents, please take some time and ask questions. You can do that in person in class, or you can leave a comment below and I will get back to you. Our next practice problem states, the graph represents the temperature in degrees Fahrenheit as a function of time. So we can see that time is the x-axis and temperature is the y-axis. Tell the story of the temperature throughout the day. Identify the maximum and minimum of the function and where the function is increasing and decreasing. So, notice they want us to point out anytime we find a maximum a minimum, increasing, or decreasing. So, first, if 12 p.m. is right about here, 3 p.m. is right about here, 7 p.m. is right about here, and 9 p.m. is right about here, I'm going to estimate that this start time is approximately 10 a.m. So that's where I'm going to start my story. So, I first have this line segment in blue. So, starting at a minimum temperature about 10 a.m., the temperature increased quickly until noon. Next, I see this line segment right here where it is still increasing. It's just not increasing as quickly. So we could say from noon until 3 p.m., the temperature increased slower to a maximum. The next line segment we'll look at is from about 3 p.m. until 7 p.m. And we could say from the maximum at 3 p.m., the temperature decreased until about 7 p.m. And the final segment we're going to look at is from 7 p.m. until 9 p.m. And we can say the temperature decreased quickly from 7 p.m. to a minimum at 9 p.m. So we just look at each line segment independently. We describe what we see happening using those 4 key terms: maximum, minimum, increasing, and decreasing. If you have any questions about how to take a graph and explain what's happening in the situation, please ask for further clarification either in class or by dropping a comment below, and I'll get back to you. Our next practice problem: match each feature of the situation with a corresponding statement in function notation. So on the left, we've got the feature, and on the right, we've got function notation, and we need to identify the feature on the graph and then use that point on the graph to identify the proper function notation. So, our first feature on A is maximum height. That means the highest y value we can find. And I see that right here. And if I look down, I see that happens when my input is 4. So that means the maximum height matches up with h of 4. Choice B, we have minimum height. So now we're looking for the smallest y value. So if I look at this graph, my smallest value happens here where I'm putting the blue dot, and I can see that that happens between 1 and 2, so that means our minimum height matches up with number 2, h of 1.5. Feature C, height staying the same. Well, if I want the height to stay the same, what I'm looking for is for the line to go sideways. Because if it's going up, then the height is increasing, and if it's going down, then the height is decreasing. So the only time the height is staying the same is when the line is going sideways. And we see that happen right here. And that happens from x being 7 seconds to x being 8 seconds. And we see that the y value at this point is halfway between 4 and 8, so that would be 6. So that means C matches up with number 4. H of t equals 6 anytime t is greater than or equal to 7, but less than or equal to 8. And finally, we have the starting height. Well, the starting height is going to be my vertical intercept, or my y-intercept. And I'm going to find that at this point right here. So that's going to match number 1, where we say this point appears to happen right about y equals 7, while x is 0 seconds because it's the starting height. If you have any questions about how to take a graph, identify these important features on the graph, and then match them to the function notation that represents them on the graph, please ask for clarification. If you're in class, just get my attention, ask the question. If you're online watching this, just drop a comment and I can get back to you. Our last practice problem. Here are the equations that define three functions: f of x, g of x, and h of x. And in each of these questions, they're going to ask us which function value is the largest. For number 1, we're going to use 100 as the input. For number 2, we're going to use negative 100 as the input. And for number 3, we're going to use 1 over 100 as the input. So first, on number 1, f of 100 means 4 times 100 minus 5. 4 times 100 is 400. And 400 minus 5 is 395. Next, we have g of 100. That's 4 times 100 minus 5. 100 minus 5 is 95. And 4 times 95 is 380. And finally, we have h of 100, which is 100 over 4 minus 5. 100 divided by 4 is 25. And 25 minus 5 is 20. So here, f of 100 would be the largest. For number 2, now we're going to use negative 100 as the input. So f of negative 100 becomes 4 times negative 100 minus 5. 4 times negative 100 is negative 400. And negative 400 minus 5 is negative 405. Next, we have g of negative 100. This becomes 4 times negative 100 minus 5. Negative 100 minus 5 becomes negative 105. And 4 times negative 105 is negative 420. Finally, we have h of negative 100. That becomes negative 100 over 4 minus 5. Negative 100 divided by 4 is negative 25. And negative 25 minus 5 becomes negative 30. So when we compare these functions, h of negative 100 is the largest, because negative 30 is bigger than negative 420 or negative 405. And for number 3, we're going to have f of 1 over 100. So that is 4 times 1 over 100 minus 5. 4 times 1 over 100 is 4 over 100. 4 over 100 can be simplified to 1 over 25. I'm going to rewrite this negative 5 to be negative 125 over 25. And now 1 over 25 minus 125 over 25 becomes negative 124 over 25. Or negative 4 and 24 25ths. Now we can do it with g of 1 over 100. That becomes 4 times 1 over 100 minus 5. But I'm going to rewrite this 5 as 500 over 100. One over 100 minus 500 over 100 becomes negative 499 over 100. Now, when I multiply 4 times negative 499 over 100, the 4 can be divided by 4 once. The 100 can be divided by 4 25 times. So this becomes negative 499 over 25, or negative 19 and 24 25ths. And finally, we have h of 1 over 100. That becomes 1 over 100 over 4 minus 5. Dividing with a fraction is the same as multiplying by its inverse. So 1 over 100 times 1 over 4 becomes 1 over 400. Minus 5, which I will rewrite as minus 2,000 over 400, and that equals negative 1,999 over 400, or negative 4 and 399 over 400. So if we compare these, on A, we had negative 124 divided by 25. That was negative 4.96. On H, we have negative 1,999 divided by 400. That is negative 4.9975. So that means F is bigger than H. So on number 1, F is the biggest. On number 2, H is the biggest. And on number 3, F is the biggest. If you have any questions about any of the practice problems we went through in regards to the features of the graphs, how we use the graphs to answer questions about functions, how we can compare the size of different functions using the same inputs, if you have any questions about anything we went over in these practice problems, please ask for help. If you're in my class, just use class time to ask for that clarification. If you're watching this online, simply leave a comment below. I'll get back to you with any help I can provide you. But I hope this makes sense to you. I look forward to seeing you in the next lesson. Goodbye for now.